Well, let's look at learning objectives D and E. I'm going to show you how to compute a residual for a data point and to compute the sum of the squared residuals for an entire model. When you want to determine how well the line you came up with fits a model, what you have to do is compute some residuals. So let's talk about what a residual is. A residual tells how far away data are from a chosen model. Another word you might hear for residual is the word error. Okay. So to find a residual, we need to first know what an observed value is. That is the data that is collected from the sources, such as experiments or surveys. The observed value is actually the ordered pair data that you got. So it is a scatter plot itself. Whereas the predicted values are the values predicted by a model. So when you come up with an equation of a line, that's the model, and when you use that to predict, that's a prediction. To compute a residual, all you do is you take your observed value minus your predicted value. Now, you're either going to get a positive residual value or a negative residual value. If it computes back with a positive value, it means that your observation value is above the line of best fit. Because on here, for example, if we look at this graph, this blue dot right here is our observation. If we go down into the line, that's what the line will predict. Well, that blue dot is sitting above the actual line that it would predict. So the observation is higher, the prediction is lower, so the residual will be positive. On the other side, if the residual is negative, for example, this guy right here is going to come back with a negative residual because the observed is below the line and the prediction is on the line. So in that case, the negative residual value implies you're below the line of best fit. Now, the smaller the residual, the less error your model has. So let's be more specific and let me show you how they are calculating the residual. I'm going to write the formula down first. The residual, again, is going to be the observed value minus the predicted value. So they have here an ordered pair already figured out, and what they've done is they taking a look at this observed value of the carat weight of one of the diamonds was 0.16 and the value was 507. So the observed value for the carat that weighed 0.16 was 507. So that's what they did here, is they took for their residual calculation, they took the observed of 507. Well, they took the value of the x of 0.16 and put it into what they think is their model. So they did 2400 times 0.16 and added 400 to it, and they got that the answer was 784. So that was their prediction. So they put that here. Observed minus predicted in this case gave a negative residual value of negative 277. Remember, if it comes back negative, it means the observed is below the line that predicts the value. Now let's do our own. What if for the carat weight of 0.33, what is the residual for that? Well, here is the ordered pair right here. It's this one here, and it's the ordered pair 0.33. We observed the value was $1,417.50, so I'm going to put that right here as the observation. And we're going to subtract from it the prediction. Well, we have to find the predicted value, so I have to use the equation that they came up with for their prediction. We're going to take the 0.33 and we're going to put it in for x. So now what we really need to do is take the formula for residual and compute what's called the sum of the squared residuals. All the sum of the squared residuals is this. For every ordered pair on our scatter plot, we're going to take the observed minus the prediction, which means we're going to compute the residual. Okay? Once we compute the residual, we're going to square that residual, and then we're going to add it up. After we do that for every ordered pair, we get the sum of the squared residuals. And then what you're going to do is, for example, down here, we have our diamond information again. And on this, we have two different people came up with two different models. Someone thinks this is the right equation to predict prices of our diamonds. Someone else thinks this is the right equation. So what they did for every ordered pair, again, they came into here for this one, and they said, all right, for that red dot, I'm going to do observed minus predicted and square it. They did it for this dot. They did it for this dot. They did it for all the dots, and then they added up the totals. When they did that, they got 237,800 as a sum of the squared residuals, or the error. They did the same thing for this model. When they did this model, they came up with a sum of the squared residuals of 59,870. Well, which model has the least amount of error? Well, it's the second one by far. So you use this formula to help you decide which model is better. I'm going to scrap this one, and I'm going to pick the one with the lower sum of the squared residuals. Now let me show you how to compute the sum of the squared residuals by hand, because you're going to have to know how to do it for homework. So what someone did is they gathered some data about various countries, and they asked how many TV sets were owned for every 100 people. So for example, in Argentina, out of 100 people, there were 22.3 TV sets. When you hit the Netherlands, there's 51.8 TV sets per 100 people. So then they went and they asked the data, what is the unemployment rate per 100 people? So in Argentina, out of 100 people, 7.8 don't have a job. In the Netherlands, 4.5 out of 100 people didn't have a job. They made a scatter plot of the data, which looks like this. So on here, the TVs are on the x-axis, the unemployment's on the right. So what you're seeing on this data set, it looks like as the number of TVs per 100 people increases, the unemployment rate of the people actually goes down. So maybe there's a connection between the more TVs you have in your household means you have more money to buy the TVs, which means you're working and you're not unemployed, so you actually have a job. Now, they want us to compute the sum of the squared residuals, thinking that the right equation is y equals negative 0.3x plus 17, where x is the number of TVs and y is their unemployment rate. So let's compute look at the observations, the predictions, and the residuals and squared residuals. Now, for Argentina, what did they actually observe was the unemployment rate? Well, it's 7.8. So that's what goes here in the observation. The observation is what the y value is in this case. Okay, now how do you find the predictions for all of these values? Well, it takes some time to do, but it's not hard. The prediction just says use the model. So you have to take all of the x values and you put them in here. So for example, for Argentina, I would do a negative 0.3 times 22.3, and then I'd add 17 to it. If I do that for Argentina, I'm going to get 10.31. Okay, now let's do the residual. Fine, observed minus predicted would be negative 2.51. Now I'm going to square that number. If you square negative 2.51, you get 6.3. Now I'm going to do that same thing for the rest of the countries. Once we have done that for all of these countries, we're going to take this total and add it up, and that's the sum of our squared residuals. So here's what all the data would look like, and if you want to just follow one more, I'll show you where I came up with the number for Bulgaria. So the observation again was just 6.3 is unemployment. To find what the model would predict for the unemployment, I just put 40 in for x and simplified this, and I got 5. So for the residual, we did observed minus predicted and got 1.3. And then I have to take the residual and square it and get 1.69. I did that for all of the countries and added it up and got 186.03 as the sum of the squared residuals. Now, by itself, that doesn't mean too much. What we really would want to do is compare it to another model to see which is better. And I will tell you, if we had the equation as this instead, if it was y equals negative 0.15x plus 12.4. If I computed the sum of the squared residuals, the only thing that would change is this prediction would change for all of them, which would make the residuals and the residuals squared be a little bit different. When you do that, you would get the sum of the squared residuals as 172.31. So doing that, what it would tell you is that this second model is actually a better model than the first one up here.